Hello everyone, this is Sakshi and I welcome you all to my Reddit platform, Way to Learn. So, we are going to solve some of the problems from thermodynamics today, and it will be like around this PYQs from CSIR net exam from June 2011 to December 2019. I have already given some few important formulas and important points required to solve problems, and also if if in the question there are anything else that is important, I'll be adding that and I'll be giving a revision of thermodynamics at the end of the PYQ session. Okay, so let us see the first PYQ session today, which is from June 2011, and consider the transition of liquid water to steam as water boils at a temperature of 100 degrees Celsius at a pressure of 1 atmosphere. Which one of the following quantities does not change discontinuously at the transition? So this question basically belongs to the transition. So I have not talked about the transition in my last videos of thermodynamics. So let us see what is transition, like what are the two kinds of transition and what is continuous and discontinuous. So this the first order transition and the second order transition are the two transitions, and the examples of phase transitions are nothing but for first order transition the examples are solid to liquid transition or liquid to vapor transition. So in solid to liquid transition, uh, what is continuous and what is discontinuous? So in first order transition, Gibbs free energy will be continuous, and the first order derivative of the Gibbs free energy will be discontinuous. Just remember this: Gibbs free energy will be continuous in the first order phase transition, whereas the first order derivative of Gibbs free energy will be discontinuous in first order. So let us see the second order. It is similar. Here, Gibbs free energy will be continuous, and first order derivative of Gibbs free energy will also be continuous, whereas the second order derivative of Gibbs free energy will be discontinuous for second order phase transition. So you can just remember for first order derivative is discontinuous, for second order derivative is discontinuous. And the examples are paramagnetic to ferromagnetic, helium 1 to helium 2, liquid to vapor transitions at critical point. Okay. So remember these examples. So wherever you have any question regarding to these examples, you can just identify whether it is first order transition or second order transition, and you can check out which is continuous and discontinuous. So in this question, it's basically transition of liquid to steam. So liquid to vapor, right? That would be the first order transition, and which does not change discontinuously. Okay, so here Gibbs free energy will be continuous. Okay. So answer will be Gibbs free energy because it's first order phase transition. Okay, so let us see the second question, which is again from June 2011, and a particle is confined to the region x greater than equal to 0 by a potential which increases linearly. The potential is given here, which is u of x, u naught of x. Okay, which is equal to u naught of x. Okay, this is actually u naught into x. Okay, and then the mean position of the particle at temperature T is. So we have to find the mean position. Mean position, we can also say mean position as average position, average of the position, or expectation of the position. Okay, they all mean the same thing. So first thing, we have a potential which varies with respect to x, right? U is equal to u naught into x. Now, the potential, according to virial theorem, if the potential varies as x power n plus 1, then T will be equal to n plus 1 by 2 into E. So, this was a formula which I haven't discussed to you. So, you can just write this, and also the first and second order phase transition, you can also write this. Okay. So, next, we have to find the mean position. So, first, we are going to um, consider like u of x is equal, our potential given u of x is equal to u naught of x, and u of x is proportional to x. So therefore x power n, yes. So here if we compare it with x power n plus 1, n will be 0. So now your t will be half into v, and the total energy will be t plus v, which is half into v plus v. E is equal to 3 by 2 v. Okay, so you have found energy over here, but you need to find the expectation value, right? So why did we find energy over here in respect to potential is, because you have a potential in your hand and you know that the energy is 3 by 2 kBT. Okay, so this is like thermodynamics question. So if you remember, E will be basically equal to 3 by 2. Total energy will be equal to 3 by 2 kBT according to equipartition theorem. Okay, so energy is 3 by 2 kBT, and now I'm just equating that with the potential, and now my potential is equal to kBT. And I also know that my potential is equal to u naught into x. So here V is basically the expectation, right? Expectation of this is the expectation of V. So basically I take the expectation of the given potential. So here it will be u naught into expectation of x. So I'm just going to equate my V and V with kBT. So kBT is equal to u naught into x. So my x will be kBT by u naught, which is equal to option A. Okay, so let us see the third question. Here, a cavity contains a black body radiation of temperature T and specific heat per unit. Okay, specific heat is also given, and this is a black body radiation. Okay, the cavity is expanded to twice its original volume and allowed to equilibrate at same temperature. Okay, so first the cavity is expanded twice its original volume. If the volume first was V, then it was expanded to 2V and then allowed to equilibrate at the same temperature. But they are at equilibrium at the same temperature T. The new internal energy per unit volume is. So the internal energy change, what is the internal energy change is asked. So we basically know that the specific heat per unit volume is CV by V, which is given as gamma T cube. And yeah, so here we know that CV is equal to dou U by dou T. This is the formula, okay. So dou U will be equal to CV dt, and you can directly integrate your CV and you're going to get the internal energy. Okay, we are not going to consider the volume term here because there is no dependence of CV on V directly. Okay, and even if you have to consider the volume term, that is CV is equal to V gamma T cube, and then again you take the other CV, which is CV is equal to 2V gamma T cube. You can do that. You'll also get the same thing. What is the difference is you'll have to take the difference of the two internal energies. Okay, so once you take the difference of the two internal energies, you are going to get the same internal energy. So this is a simple thing we can do instead of going into a big process. So I hope you understood all these three problems. So thank you. Like my videos, share my videos, subscribe my channel, and don't forget to hit the bell. So I'll be coming with more questions and more problems and more important formulas required to solve for problems from thermodynamics. So hope you enjoyed this session. So thank you. See you tomorrow. Ta-da.